we will talk about pointers, arrays, and if you remember, we were trying to learn some loops and some branches, flow diagrams, etc. And we were about to start arrays. So I wanted to make this session in C because if you can do those array stuff or memory management in C, then you can do it on anywhere. And C++ will be much easier and C# will be a piece of cake. So let's start talking about boxes again. I know you are bored because of those boxes, but we will always use those boxes, okay? I can't imagine otherwise. In our first sessions, we talked something like this. You can think variables like boxes, right? They have a size in your memory, in your PC's memory, not your memory. They have some fixed size when you write something like int a name, right? And let's see what's happening behind. So in reality, when you write int or float or char, actually you just set the size. You're just trying to explain that, okay, I will hold something which is 32-bit, or in some cases it can be changed to 16-bit anyway. So you just set the size of a variable. That's all. And you give it a name, right? So those names actually represents the reference of the variable. So let's make something like this. So let's assume we create a variable and let's make it 5. Let's make another variable, set it to a. Okay, so it's very simple, right? We all know what's going on here, but not so deeply. So let's see what's going on. Okay, so I put some breakpoints and I will debug my program. This program will run step by step. Okay, so as you can see right now, it shows a random value, right? We will set it to something, but it's not set yet, so it gives us a random value. In other languages like C#, they have some default value like 0 or something. Okay, so I played my program just one step, and right now we see this, right? So it shows me that we have a value called a, and it's integer, and its value is 5. So it's still the same. When we create the int b, it just checks what is the value on a. Like, you should think about this. Let's assume a is, okay, let's change it this way. Let's call this box a, okay, and let's call this box b. So when you do this, you just create this box, okay? When you assign a value to it, you just set a value inside this one, right? When you use the assignment operator again, like int b equals a, what you do exactly is something like this. So I will set some value for b, and it says, okay, I will be value of a. So computer goes here and checks, okay, I have 5 here. Okay, I will copy this value. This part is very important. I will copy this value to here, okay, and this will be 5 too. So let's see another thing, which is pointers. You all know at least what is a pointer. I mean, at least how it looks, right? So a pointer is some type and star, and let's call it PTR. So let's draw what pointer is. We draw those values like this, right? So you can think about pointers like this. I mean, it's an abstraction. It is not the real thing, but just try to think this way because it will make everything easier. So this is a pointer. It has some arrows like this. Okay. So when I write this, I just create something like this. Okay. An arrow with a name. It's not set to something right now. It's just pointing some random place. So let's make it point where this variable in our memory. So write something like this. PTR equals $a. So this syntax means I need this one's address, right? This one's address in memory. Okay. So when I do this, I just simply say, okay, I will show what a is. Okay, so I mean, a is also showing some place in memory, right? Actually, we can change our abstraction like this. We can think like this. Put another arrow here. Okay, let's put another one to here. Okay, so you can simply assume when you create a variable without pointer, just simple primitive variable we all know. This is just saying something like this. Its name is this. I already allocated the memory for this variable and I set this value. Okay, but when you create a pointer, you can think it like it will just point something. So it's pointing A. It's not pointing this box. It's pointing A. So if at some point where A is pointing changes, it will also change without doing anything. But since A is not a pointer, it won't change the address, but you got the idea, right? So let's debug this one again. So our program starts, it set the value to 5 and we see something here. It says it's 0x1000. Do anyone know what is it? And I just make it run one more step and now we have something more ugly, right? So do you know what it is? Anyone? Yes, it is the address. And yes, it is hexadecimal. Do you have an idea about hexadecimal? Let me explain it quickly. Hexadecimal is just values between 0 and 16, right? So in normal decimal counting, let's say you write something like this. Okay, let's assume this is your number. So how do you know the value of this number? It's just this, right? 10 power 1, 5, 10 power 2 times 4. It also applies to binary, like if the value is something like this, that means 2 power 0 times 0, 2 power 1 times 0, and 2 power 2 times 1. So it's actually 10 in decimal value, right? This is the same. So when you see something like this, this means it's an hexadecimal. After the 9, there comes the A, and then B, C, D, E, F. F means 16. Okay, this is just an address in memory. Right now, we are able to see the address, right? So the pointer assigned this address. So it now becomes this value because this is the real address of our integer in memory. Let's have a look at it. I think we can copy this one. Yeah, copy address. So okay, see, this is almost real place where your data is in your PC. Okay, so if I change values here, data's value will change. See, now it seems like a very huge number. It was 6 on its original, right? Because I'm just change value inside the data, the real place. So this is the address. The left side is the register address of the data, and these are just hexadecimal values. So I can set anything here and it will change the value. So I can change the A from just changing the value in this memory address. I think it's pretty interesting, right? So let's talk about arrays. Let's say this is our array. So what that means, when you write this code, it simply means I will just create 10 boxes, okay? Not one, but 10 boxes, and they will be close in memory, like the next integer size of memory will be the next one. So I just make them together, right? Let's assume there is 10 boxes here, or let's change our array to 7. So that is actually it. There is nothing special about it. And what we do in the background, we just create a pointer which points to these values, okay? It just points to the first value in array. Is there any advantage to using arrays compared to lists? I pretty much only use lists in my unit project because I have much more control over them. Yes, there is an advantage of using arrays. I don't know if the advantage is so big in C# or Unity, but if you are sure about the size, I mean, you know, the arrays are static. These are fixed size. They won't increase their element size. So the common practice in Unity is like this. Let's say assume the rest of the code is some mono behavior, okay? So if I will expose the values into inspector and drag and drop them, you know, I just simply do something like this. Serialize field and my values. So this way Unity creates it on inspector, and on inspector you can set the size. But if the size is fixed, so it has to be more performant. I am not 100% sure. I mean, I am 100% sure, but I don't know the impact on Unity side, but it must be more performant because the size will never change. Actually, I wanted to explain all of this in C because I want you guys to understand how these things works. Okay, UE isn't like that, is it? In Unreal Engine there is something called T array, and it is their way of optimizing things. So you don't create arrays in Unreal like this way, but you create like this way, and I think it was like this. Yeah, so you create them like this way and they handle the optimization part, you know. Because I always use array and without setting. Yeah. I mean, those are not huge impacts on your code performance. I mean, I don't want to look like someone obsessive. It's not the issue. I just want to explain how those things works. Okay. So yes, arrays are more performant than lists. But what is lists in reality? You know, let's first make some more examples, some easy stuff. So you can set array values like this, right? It is simple. And if you want to assign some values in a for loop, we were planning to talk about for loops. Let's say our array was in 7 size. We can just do this, right? Let's say we will loop through all the elements of the array, like e will be 0 at first, array 0 equals 0 multiplied by 5, 0 times 5, e will be 1, and 1 will be 5. You know, this is some usual syntax for looping through an array. Let's see how all those listing works. I mean, we are writing some code which is very close to machine code, okay? So in reality, this syntax is just something fancy. What it does behind the scenes is something like this. Say array2, okay? So now I will make them an integer pointer. So this means I will show something which is in integer size, okay? And in C language, I can allocate memory or free the memory however I want, okay? So let's write the syntax first. I will explain it later. Also included the standard library. This is the same thing with above, because what I write here means, okay, return me an integer pointer, which is something that we allocate in memory. This malloc thing does this stuff. I will allocate some memory which is in size of an int, but 5 times, okay? So this is just saying something like this. Instead of this notation, you can think like this. I just said, okay, an integer is in this size, then with malloc I just said allocate this amount of memory for me. I will use it in some way, okay? So you can use it in any way, like 5 elements in an integer. Let's try to assign some values to it. Let's do another for loop again. So if you have the standard thing for arrays, you just do this, right? So if you have a pointer, you can also point somewhere which is different than this, because if you remember, this one will point here, right? This will point this place, not the rest of the element. But there is something called pointer arithmetic. This is also not presented in C#. So let me show you first how it works. Okay, those are almost same expressions, except I just multiply one of them with 3 and one of them with. So what I did here is, when you use this notation, you say array 0, array 1, array 2, right? This is totally same thing, because this means there is an sorry, that must be array 2, because we were using this one, right? So use array 2 address first and add I. So I is 0, 1, but it can be a little bit weird, because what that means, I mean, add some memory place 2 more. What this means? This is called pointer arithmetic. So when you write something like this, it says, okay, array 2. Array 2 was an integer pointer. Then this means when I add 1, I will just shift in the memory for one size of int. Okay? And I just use that style because I want to assign value, not reference. Let's say I created an integer pointer and let's allocate some memory for it. Instead of pointing another variable, I just want some memory on. So this is almost same thing with this, right? it just does the thing itself. I mean, it's already allocated in the memory, but in this one, I don't have to do. I can point another variable, but in this example, I just said, okay, just allocate some memory for size of an integer. So now I can either do this. This means when you use the star before a variable, it means that I will set the value at this address. Okay, since pointers are basically address, right? We showed it in the debug menu. We showed some weird values. This is just it. I mean, pointers just hold some address. When you put a star before the pointer, it means that, okay, find this address and get the value of this address. So since it's an integer pointer, it just reach the address and equals it to 4. So it makes something like this. It doesn't change where it's pointing. Okay, it is totally same thing with normal int. But I would also do something like this. Show the address of the x. If I do this, then let's say when I change the value of x and print, I will print some decimal and x. Let's go step by step. Again, I will show some decimal, but this time print a, okay? And also put some backslash n for new lines. And I will print one more thing, which is star a. So let's see what it will do. Okay, first, since we assigned 13 to x, it just prints 13, right? We can see it in the console. I mean, we will see it after I resume the program, but yeah, it just prints 13, right? Right now, it will print the address because this A is a pointer, right? So it holds addresses. That's all it does. So when I do this, we see something, a weird number here, which is the equivalent of this value. I just wrote it in decimals. And when I resume the program again, see, it again prints 13 for star A because we said find this address and print the value at this address. Okay, so now it will make more sense for this part. So if you check the code again, what we said is just, okay, allocate some memory for 5 integer size and just find the memory and add some values, which is we call pointer arithmetic. I mean, find the next int size empty box. You know, if this is array 2, I mean, if array 2 shows this place, array 2 plus 1 shows this one. And if I put a star, if I put some star here, then it means, okay, find the value at this address. Is it clear? I mean, it can't clear because it's the most complicated part of C, but you got the idea, right? Do you have any question? No? Okay. We have a smart team. Cool. So let's talk about lists again. What is a list? Why you should have some concerns with lists? Let's create our list. I will just create my own list structure. Let's call it list. My list will always have some size, right? And it will hold some values. So I can use an integer pointer for it. So how can we add something to this list? We first do something like this. We first initialize the list, right? Let's write a method for initializing the list. Not size, but capacity. I think capacity is a much better word for this. So I will create some list here. Let's return a list pointer because we need the address. So list pointer, my list equals list pointer size of integer size of a list, because we first allocate the memory for list and then we will allocate the memory for this one. So let's say my list size is 0 and my list capacity is capacity. Why do I need a capacity value? I mean, in C# you don't need to set some capacity, right? Because it just set this capacity for you, you know? Because there is no way to say, okay, I will allocate some memory and the last point of this address is here. We should know this before. When you implement this list in C#, it already knows its capacity and just creates some boxes in C#.NET framework, right? It just doesn't expose this value to you. Okay, so now you will understand why lists are less performant than array, because when we add let's say this will have 10 capacity. C# will do the same thing for you. I mean, it has some optimization, but it will decide the capacity when you initialize the list. Let's say it is 10, okay? So when you add, let's say, the 7th element of this list, what C# does behind is just it resizes the memory, okay? It says, okay, we are close to capacity, then let's multiply capacity 2 times. And memory allocation is something expensive, you know, something heavy, you know. So you don't see it, but C# does the same thing with what I will do right now, okay? So this is creating a list structure. This is our fancy list. And now I will create some empty space for size of integer and capacity amount. Let's say the capacity 10. I just create empty space for 10 integers. This is what any list do. Your C# list also does the same. And I will return my list, okay? So let's try to initialize our list. Okay, how can we add values to this list? Let's create another method called add element. So it needs a list pointer because we don't have object-oriented stuff in C. I can't say L dot, you know, it won't call this method. You can also realize this. There is no scopes for list. I didn't write struct here and I didn't write those methods here to say, okay, this list has a add element method, you know. They are all separated. They don't have some bindings. So I have to give what I need, the address of list, and let's say a value. So first it checks the capacity of it. If list, I need to resize my list, right? We can add a to-do here to go back later. But as let's say we have enough space in our list, what we will do is we will get list values. And if you remember our pointer arithmetic notation, we will do this plus size, plus list size plus 1. So find this address. Which address I am looking is list values plus size because I have that amount of values already inside of it. So I need to shift in memory. And I will add one more because this is the next empty memory. We didn't use it, right? So I will make it equal to this value, right? So in each case, I will also increase my list size. So I think right now it should be a little bit more clear why lists are less performant than array. Because in array, you just say, okay, I guarantee you I will use just 10 integer space for this array. And I won't resize it. But when you create a list, what you do is, okay, I have to control the capacity. When adding elements, I have to optimize it. For example, this is maybe the worst optimization, okay? More reasonable one should be something like this. When I reach the half of the size in my capacity, I should increase my capacity 2 times. So this will be more efficient because it will always increase the capacity in a huge way. So you don't need to resize and resize again. In our bad example, what we do is, let's say we reach the size 10 and our capacity 11, we again reallocate. So this is the code for reallocate. Let me show you. So reallocate pointer will be our start point values and size is, let's say, list capacity multiplied by 2. But in any way, we should still add the value, right? After resizing. So do you understand? This is something like malloc, but it just resizes the memory. It just finds a better place in memory which can hold this amount of values. Also, this must be something like this. Size of integer multiplied capacity times, and our new capacity of course is 2 times more, and then we add the element. Is it clear? I mean, does that make sense? This is why lists are less performant. A more performant option would be dictionaries. You know, they are basically hash maps, so they have some unique index. Okay, so we can also reach any element from here this way. But as you can see, I just put some stars here. So it means I will return the value. But I can also get the reference. So the real memory place. So I can do something like this. Get element reference. Okay, so there's a difference between them. Let me show you. So we created our list with 10 capacity. Let's add some elements inside of it and let's use a for loop. Let's try to reach value, by get element. Also, let's take value pointer by this one, get element reference. So the difference is with pointers, we really get the address, right? So when you get this and let's say value is 2 times greater. And when you do this, there is nothing changed on your list because this is just a copy of the value. It is not the real address in the memory. But when you do this, and here we take the fourth element of list, if you do this like this, then in anywhere on your program, it means that this element value is changed. So this is what goes behind C#. Do you know the term call by value, call by reference? C# classes are always reference and structs are always value types. That means, let me show you. This is a value type, okay? We didn't use any pointer. When I do something this way, I just copy the value to here. So those are values. Any change on B doesn't affect A, right? But when I create a pointer, we can call it like reference. So when I do this and if I change the value at C, change the value at address C, since this is address of A, then value of A is also changed. Does that make sense? Okay. Is it clear? Okay. Makes sense. So this is all about. Also, this is also important in your C++ code. When you are using Unreal, actually it's always important because when you use anything in C#, you can't control this behavior, but you are still doing this. Let's say you have a class, okay, let's call it class A. So when you do something like this, class AX is new class A, let's assume it has a constructor. When you do this, it's actually same thing with this malloc thing, okay? So when you use the new keyword, you just allocate memory on C#, and this is a reference. Actually, it's a pointer, okay? But let's say I did this. Class A, Y is... So you inherently know when I change a value in C#, let's say it has a value called A. When I change this value, I also change the value for X because there is no malloc for Y and C# thinks it's a reference which points X. Okay, this is very, very important. Also, it's very related to performance because we don't want to copy values, right? If we are able to use references, it's good because we don't copy things from here to there in addresses in CPU. And if you want to write some game code, performance is important. And C# somewhat handles this. Okay, I think time is out. Yes. Any questions? Anything you want to ask? No? All right. Okay. Goodbye then.